Welcome back to The Explainer. Today, we are unpacking a massive, really fundamental paradigm shift in artificial intelligence. For years now, we've all been completely captivated by AI that can generate text, write code, paint pictures. But underneath the hood, fundamentally, those models are just playing a highly sophisticated game of guessing what comes next. Well, today, we're looking at a platform that is abandoning that prediction game entirely in favor of something called Convergence. Right off the bat, the overview for this system, the BuddhiEngine, hits us with this absolutely striking statement. Most AI systems today are built to predict. We're building systems designed to converge. It's a bold claim, right? It signals a major move away from just scaling up the same old transformer models we're used to and pushes us toward rethinking artificial cognition from the absolute ground up. So here's our roadmap for today's explainer. We'll start by going beyond next token prediction, then reveal what the BuddhiEngine actually is. After that, we'll compare convergence versus prediction, explore the concept of thinking before acting, look at building trust in regulated industries, and finally wrap up with next-gen gaming and NPCs. All right, let's jump right into Section 1, Beyond Next Token Prediction, the limitations of guessing. To really grasp why we even need a completely new architecture, we have to look at the current industry standard. Right now, most of the AI world is hyper-focused on scaling transformers that basically treat intelligence as next token prediction. It's just calculating the most statistically probable next word. Think of it kind of like driving blindfolded. The system is just guessing what the next few feet of road look like based on where it's been. And sure, it might string together a smooth few feet of driving, but it lacks a stable, holistic understanding of the entire environment. When you throw complex, real-world constraints at it, it's incredibly vulnerable to just flying off the rails. Moving on to Section 2, the BuddhiEngine revealed, a new foundation for reasoning. So to actually solve this blindfolded driving problem, we're introduced to the BuddhiEngine. At the very heart of this new infrastructure is their proprietary AERM architecture. And what AERM does is fundamentally change the underlying math. Instead of calculating probabilities for the next word, it frames reasoning as a stability optimization problem. Intelligence here isn't just firing off a highly probable sequence of characters, it's treated as finding the most logically stable state within a specific set of rules. And what's cool is this isn't just some isolated model you query. It's a massive, comprehensive ecosystem. At the base, you have that ARM architecture. But working alongside it, there's Guardrail DSL, which lets you enforce live, YAML-driven policies without even having to retrain the model. You've got an agent studio for building autonomous agents, causal forward models, which, hang on, we'll dive into those in just a second, an incredible 25 times pattern-based semantic compression, and an SDK that lets you integrate all of this shebang with systems like GPT-4 or Claude in a matter of minutes. That brings us to Section 3, Convergence versus Prediction, Finding the Lowest Valley. Let's really compare these two approaches side by side. Next token prediction is strictly linear. It's stepping forward, guessing step by step, almost like rolling a die over and over. Energy-based convergence, on the other hand, is like dropping a ball onto a really bumpy, complex landscape. That ball is naturally going to roll down until it settles into the lowest, most stable, and safest valley. The BuddhiEngine is actively optimizing for that stable, resting place, taking all the complex constraints of the terrain into account all at once. Meaning, the system mathematically seeks out the most logical, resting state. By using this energy state reasoning, the models literally converge toward logically consistent and policy-aligned answers. And the so what for you and me is that instead of crossing your fingers and just hoping an AI doesn't hallucinate while it strings words together, the AERM architecture practically guarantees the output settles perfectly within predefined rules. It is, by its very design, just inherently more reliable. All right, Section 4, Thinking Before Acting, Simulating Consequences. Now, a major piece of achieving this flawless logical alignment is how the system handles real-world interactions. They do this through causal forward models, or CFMs. As we know, current AI can be pretty impulsive, but CFMs operate totally differently. First, they propose an action internally. Next, they simulate the consequences of that action, and only then do they execute it. It's literally forcing the AI to think before it acts. It has to evaluate the fallout of its choices safely in a simulated environment before it ever touches the real world. And this rigorous, almost paranoid internal monologue is powered by two distinct core model families. First, you have the Sentinel family, which is laser-focused on production-grade safety and compliance, giving us models like Raksha v2.6 and Safety Monitor v2.2. Then you've got the Cortex family. This represents their next-generation foundational reasoning, featuring models like Buddhi Cortex 1 that are heavily focused on persistent memory and neurosymbolic verification. Which leads us nicely into Section 5, Trust in Regulated Industries, Zero-Mistake Environments. So, you might be wondering, where is this intense level of rigorous stability actually needed? Well, because of this massive focus on causal simulation and live guardrails, this infrastructure is absolutely perfect for high-stakes environments. We're not talking about a simple AI wrapper for writing emails here. This is cognitive infrastructure for places where mistakes are simply not an option. Think finance, healthcare, the legal sector, places where consistency, compliance, and trust are absolutely non-negotiable. Sectors where a single, simple AI hallucination could mean a literal catastrophe. To serve these ultra-serious sectors, they've actually built specific applications right on top of the BuddhiEngine. The most notable one is Raksha M. Powered by those Sentinel family models we just talked about, Raksha M provides highly specialized AI safety and governance infrastructure. It ensures that all enterprise operations stay safely locked within the valleys of strict regulatory compliance. And finally, Section 6, Next-Gen Gaming and NPCs, Dynamic and Chaotic Worlds. Okay, this is where the story takes a super fascinating turn. Because the applications for this stable reasoning, they aren't just limited to strict, boring corporate governance. Enter VegaFX. VegaFX takes these exact same energy-based AI systems and drops them into next-generation Unreal Engine 5 gameplay. Suddenly, an NPC in a video game isn't just following some rigid script or making random predictive guesses. It's using stable, multi-pass reasoning to dynamically and logically react to the player in real time. It's a real game changer. I just find it so incredible how this perfectly illustrates the sheer versatility of the BuddhiEngine. It's wild that the exact same convergent foundation that's securing high-stakes, zero-mistake regulated data with Raksha is the exact same engine empowering chaotic, highly immersive gaming environments with VegaFX. Because whether you are a banking auditor reviewing documents or a video game boss plotting against a player, the underlying need for reliable, constrained reasoning is exactly the same. So, as we wrap up this explainer, the core message from the BuddhiEngine team is incredibly clear. They are arguing that the future of artificial intelligence will not just belong to whoever can build the largest prediction model. Ultimately, the BuddhiEngine is proving that cognitive state evolution, persistent memory, and logical alignment are the real keys here. The future is going to belong to systems that can reason reliably under complex, real-world constraints. As we sit back and watch this massive paradigm shift unfold, moving from driving blindfolded to mathematically converging on the safest, most logical answers, it really leaves us with one provocative question to chew on. Will the future of AI actually belong to the biggest models or the most reliable ones? Thanks for joining me on this explainer, everyone. Always keep questioning how the tech around you actually thinks. See you next time.